later date as well. So thank you guys for being here. Here we are looking at solving systems by substitution. Let me actually add that to the top of the notes, what we're doing. Solving systems by substitution. Whoop, misspelled, missing systems. So, step one says to make sure at least one variable is isolated. So I need like an x equals somewhere or a y equals somewhere. Two more minutes. 2 more minutes till we hit the 15. Yep. So at least one variable needs to be isolated. I'm going to let you know right now, step one's a step you're not going to have to stress about. Any problems where a variable is not isolated is actually going to be more conducive to solve using elimination, which we're going to learn on Monday. So make sure at least one variable is isolated. That's pretty easy. Step two, we want to substitute what the isolated variable equals into that variable in the other equation. So if x is isolated, plug in for x in the other equation. If y is isolated, we're going to plug in for y. So you guys have said like, oh, if I know x equals 5, I'm allowed to replace x with 5. What we're going to say is, no, oh, x just doesn't equal 5. We might say x equals 2y plus 5. So you can take that entire x and replace it with 2y plus 5. Once we plug that in, we're just going to solve the new equation. So that's where having those solving steps that we went over earlier this year is key. Once you solve for that, you'll either have x or y solved for. We want to plug that solution into either equation and then solve. It really doesn't matter which one you choose. However, it can be easier or harder depending on which one you choose. And we'll talk about that when we see that in motion. And then the final step, you'll have x solved for, you'll have y solved for after the end of step 4. We're just going to write it as an XY ordered pair, telling us where those graphs would cross. So I'm going to give you a minute to make sure you got this down. Again, I can see if you have questions. I'm just going to say, hold on to your questions for right now, because we're going to see this in motion. This might make more sense once it's all in motion. So just get it down, try and see what we're doing, and then we'll see it in motion in just a few minutes. So with these, one thing we're going to look at is the idea of graphing as well. We will graph to confirm answers. And here's the thing, I'm not going to say that's what we're doing for all these problems. I'm just going to show you that, hey, our algebra lines up with our graphing. So we see this as a 5-step process, but like I said, step one, a lot of times is already gonna be done for us. And if step one's not done, if we don't have at least one variable isolated, we're probably gonna look at a different method of solving than substitution. So really, even though I wrote 5 steps up there, we're really only engaging with 4 of them. Those of you that are still writing, still fine, give you the time to make sure you got these notes down. So see pencils moving across the classroom, so we're waiting till we're ready. We're just starting on the notes, okay? Sure, I'm not blocking anybody's view too bad. That's probably better. Really, when we look at this whole process, step 2 is the only thing that's gonna feel really new. Once we do step 2, step 3 is gonna be the same stuff we were just doing last week with solving. Step 4, once we plug in, again, it's just gonna be doing that same stuff we were doing solving. So step 2 is the only place we're gonna feel like, wait, this feels a little more new and different than something you may have done in the past. It's not going to be completely foreign, but it may seem a little different than something you've done before. 1, 2, right? Sorry about that. So there's the pencil sharp. So let's look at this in motion. So first step we said, whoop, move that around. First step we said was to isolate. Do we have like a y equals or an x equals in this problem to start? Do we have y equals or x equals happening in here? Yeah, I have y equals 2x. I also have y equals x plus 5. Now, again, with this, I'm going to just say, okay, right now, this is isolated. Y equals 2x is currently one of my isolated things. Now that I know that that is isolated, what I'm going to do is I want to plug in 2x where I see y in the other equation. So instead of writing this y equals x plus 5, what I'm going to do, and I'm going to actually zoom out this way, is start. So y equals x plus 5 now turns into 2x. Is 2x equals that. Just continue writing this. So all I did was take the y out and replaced it with 2x. Now, when I look at this problem, we were solving stuff like this just last week, right? So do I have anything to distribute on this? Well, remember, with distribute, do I have parentheses going on here? No, but I have x's on different sides, right? So how do I get rid of this x over here? Good. We want to subtract it or minus it. So I'm going to subtract x over here and subtract x over here. 2x minus 1x is just x is equal to 5. Is this solved for? X is by itself, right? Okay, we're halfway done. And actually, we did the harder half already. The back half of these tends to be going more downhill. So if I know x is 5, I need to plug that into one of my original equations. It does not matter which one you plug into. This one, they'll be of equal difficulty. So let me know, do you want to plug into the top equation or bottom equation? Sure, let's go with the top equation. It really doesn't matter which one you decide to say. So what I'm going to do is take this x equals 5, and I'm going to plug that back in to my top equation. So that's going to give me now, I'm going to use black for what is coming from the original problem. So that's y equals 2, but instead of putting x, what can I put? 5. So y equals 2 times 5. 2 times 5 is just 10, right? So I get y equals 10. Now my final step says write it as an ordered pair. So what's my xy pair here? What's x? What's y? 5, 10 is my answer. So if I were to graph these, which we'll look at in a second, I want to make sure you have the example written down before I graph them. When I graph them, we'll see them cross at the point 5, 10. Mask up, please, mask up. So, so all the ones we're gonna see are isolated with at least one variable. When neither variable is isolated, that's where elimination is going to come into play next. I should say that a little louder for everybody. So got a great question. Hey, what happens if a variable is not isolated? In normal practice, I'd say, well, okay, we're going to isolate it. But look, I'm trying to get us through this material in a reasonable amount of time. If a variable is not isolated, most likely that problem is better suited to be solved using elimination. And we're going to learn about that on Monday. So everything I give you is going to have at least one variable isolated. Sometimes they'll have two variables isolated like they do here, but we'll always have at least one isolated. So let's look at this on Desmos quickly. So if I go to Desmos, I can just graph this. This was y equals 2x and y equals x plus 5. Oh, that's going off my graph. Well, we can just move our graph to see. And lo and behold, the algebra we did told us that these lines should intersect at 5, 10, and that's where they did. Now, a lot of our graphing before, we were able to see where they intersect inside this default window, right? So that's again showing a flaw with graphing. Sometimes we'll have to move the graph around to find where they intersect. Any questions on this example right now? So there's a lot of skills you already had for this. It's just a matter of putting them all together. Oh yeah, I got two more right after this. I just, looks like somebody's just writing down the very end of this, so I want to make sure they got it before I move on to example 2. Yeah, I got 3 examples with this. While I know one was probably pretty helpful for you, I know that's not going to be enough information or enough help or support to get you all the way there. So let's look at this one. This says x equals 2y minus 4 and also x plus 8y equals 16. Do I have something isolated here? Do I have an x equals or a y equals happening anywhere? Yeah, I do. What is it? So x equals 2y minus 4. That's my isolated bit. So what is going to happen there is that's going to replace x in the equation below it, right? So instead of writing x, I'm allowed to replace that with 2y minus 4. That's what we're going to start here. So 2y minus 4 now equal, or sorry, not equals. So it's an x plus, so 2y minus 4 plus 8y equals 16. Stop it right here for a moment before I solve. Any questions on how I created my new equation with all y's in it? So when we have things with x's and y's, we can't just solve for the variable. But when something's all y's or all x's, we can. So that was my goal here. So I'm not seeing any questions on this step right now. Let's get to solving. Do I have anything to distribute here? Do I have any parentheses going on? No. Do I have any like terms on the same side? I do. I have 2y and 8y, right? What will 2y plus 8y give me? 10y, perfect. So we get 10y minus 4 equals 16. What would I do to finish solving this? Add 4. $10y equals 20. What do I do to finish solving for y there? Divide by 10. When we divide by 10, I get y is equal to 2. Now here, this is one where for difficulty purposes, it matters which one we plug into. We plug into the easier, there's an easier one to plug into and a harder one to plug into for figuring out the answer for x. However, it doesn't matter which one we actually use to get the answer. So now that I know y equals 2, do we want to plug into the top equation or the bottom equation, do you think? So the bottom's not bad, but I'm going to let you know the top ones actually are easier route. And the top one's easier because see how the top one says x equals? That just means I need to plug into here and then do the math. If I plug into here, I'll multiply there, then I have to solve. So that's just slightly more work, right? Not saying that you can't do it, because you can. Good morning, Mr. Ingram. What's up?
10 seconds.
Yep. So go ahead and try to plug 2 into the top equation and see what happens. Yeah, I got you. So let's plug that into here. So now this can say, starts out x equals 2, and then instead of saying y, I'm going to plug in 2, and then minus 4. What's 2 times 2? 4 minus 4 is? So I get the point. Let's switch it up to purple. X goes first, 0, comma, my y, 2. So again, we're utilizing a lot of skills you used before. That plugging in one equation to the other, that's really our big new idea. Everything else from there goes, hey, this should feel at least somewhat familiar. So we'll look at that graphically in a second, and we will see. Now, here's the cool part about Desmos. If we were doing this without Desmos and we had the TI graphing calculators, I go, both these equations are a pain to graph. Desmos lets me graph any equation no matter how it's typed out. So I can type those into Desmos and see their graph, even though they're not in the traditional y equals format. So can still graph them and see where they cross. So let's take a look at those two graphs. So this one, first one said x equals 2y minus 4. Whoa, did not delete enough there. There we go. And then the other one said x plus 8y equals 16. Whoop, that did not type anything. X plus 8y equals 16. So we see these two, and lo and behold, they do cross at that same point we got algebraically, 0, 2. That's it. So that's, using our graphs to support us. I do need to see all the algebra. I need to see all the work when you're doing this. So if you're not showing your work, that will be a minor issue. I need to see the work supporting it, but here's the thing. You guys have Desmos. You can quickly graph both lines, see where they cross to make sure you're getting the right answer. So that's something you can use to your advantage. Figure 2 examples probably aren't enough. Let's look at a third. This one is slightly more complex. This is about as complex as it will get. And then I'm going to say, try the rest on your own. So you should have a solid 25 minutes to get started on this. Tomorrow we'll answer any questions. We'll use those as like our next set of examples. So if I need to go over number 5 from the work, I'll go over number 5 tomorrow. So let's see here. I have y equals 5x minus 7 and 3x minus 2y equals negative 12. Do I have an x or y that's by itself? Yeah, I had the y and the y equals 5x minus 7. So that's my isolated. That will go in for y into the other equation. So my isolated is y equals 5x minus 7. Now, when I start looking at the other equation, I don't plug it until I get to the y. So it starts out negative 3x minus 2. Well, what am I writing now instead of y? Times, well, not just the 5, the whole thing, right? So that's going to be 5x minus 7. So I put that in parentheses because I got that 2 in front. And now that will equal negative 12. So I know space-wise, this is a little cramped, but it's okay. Looking at this, do I have anything to distribute here on this one? I do have parentheses, right? So I'm going to start with distributing the negative 2. Just take your time on solving with this one. You guys have the skills for it. So that's going to be negative 3x. 2 or negative 2 times 5 will be minus 10x. Negative 2 times negative 7. Well, that will be a positive 14 is equal to negative 12. Do I have like terms to combine here? Yeah, the minus 3x and the minus 10x. Combine those. You guys got it. Give me negative 13x plus 14 equals negative 12. And right away, some of you might be saying like, oh, I don't think this is going to work out nice. Let's just trust the process. What would I do here? Subtract 14. And that gives me equals negative 26. What do I do to finish it up? Divide by negative 13, and actually we get a really nice answer here. X just equals 2. So now that we know what X is, does it look easier to plug into the top or the bottom equation? The top's easier because we already have a variable isolated. Now you want to plug it into the bottom. Go ahead, be my guest. You'll still get the answer right if you just follow your math. But the top one's going to be easier for us. So I'm going to take x equals 2 and plug it in to x up here. So that gives me y equals 5. Then instead of writing 2, or sorry, instead of writing x, I plug in 2. And then that's minus 7. What's 5 times 2? 10 minus 7 is? Y is 3. So we get the point, a solution of 2, 3. If I do graph these lines, which we will do in a minute, we will see that they intersect at the point 2, 3. So utilize how we learned to solve by graphing to help you check your work for substitution. I know we're kind of shortcutting it, saying just go into Desmos and click where they cross, whereas when we actually graphed it, I was like, make sure you know how to accurately plot the points and graph the lines. And now I'm just saying, like, hey, you practice that. Let's just take that big idea of graph them and see where they cross to help us out. So very quickly, let's take a look at this graph. So this was y equals 5x minus 7. And then I think it was undo. I did not want to delete all that. There we go. Negative 3x minus 2. Y equals negative 12. Oh, I forgot a y in there. That would throw it way off. There we go. So I typed them both in. I'm still getting that same point where they cross. 2, 3. So it didn't matter that I used my algebraic methods. It still gives me the same answer as my graphing methods. So it doesn't matter which one you really choose. However, on the quiz, I will say, I want this problem done using substitution or elimination or graphing, or whatever method I tell you you need to do it in, it will be the ideal method to solve it with. So I'm going to stop our recording.